the first step of that is to establish what you're actually studying. I observe a natural phenomena and ask, why is that happening? And that's normally where most people go wrong.
Don't go too deep into the rabbit hole. So related to what I was doing, I was trying to describe something which I called an experiment, which I wanted to relate to the question, why do the celestial objects move in the manner in which they move? So if you can relate it to how that is not an experiment, that will be much more helpful to me.
Yeah, if you're observing the path of the stars, then the path of the stars is your effect that you're studying. Therefore, in the hypothesis, what you'll have is a presumed cause for that very specific effect. People jumped all over you because of your use of the word science, right? And I said, we'll come back to it because I don't want to seem pedantic in the middle of the discussion and point you're trying to make, right? But there was a very specific reason why people jumped on you when you used the word experiment. And if you're...
No, that's okay. I have no problem. I have no problem with people objecting to stuff. Actually, I'm all for it. So, just...
Well, the main reason is because we've been deceived in that regard, right? So we've actually been led to believe that we've got scientific validity for the globe Earth and such like, and we just haven't. So knowing what science is... Go on.
As I'm saying, I have no problem with people jumping all over my arguments. Actually, I'm all for it. So if I say something wrong, just have at it.
Yeah, it's common to do it, though. It's not like it's you as an individual. It's just everybody does it.
No, that's perfectly fine. I'm just saying I have no problem with it. That's all good. I'm not made of porcelain, so I can take it. Let's go.
When we did go through it in terms of the scientific method, did you follow along with what we were telling you?
I haven't been able to follow a few points where you were arguing why it's not an experiment. I didn't really catch what was the crux of the matter there.
Okay, well, in terms of what science is, if you understand what science is, you can then understand what it isn't. So when people say science, they're specifically dealing with the cause and effect relationship that you'd set up in an experiment. So the first step of that is to establish what you're actually studying. I observe a natural phenomena and ask, why is that happening? And that's normally where most people go wrong, because they'll start with something that either is a question of what is, as opposed to a cause and effect question, or they'll ask a question about something that's been induced by man, a man-made effect, a synthetic effect.
Just a second. Don't go too deep into the rabbit hole. So related to what I was doing, I was trying to describe something which I called an experiment, which I wanted to relate to the question, why do the celestial objects move in the manner in which they move? So if you can relate it to how that is not an experiment, that will be much more helpful to me.
Understand what is an experiment is to then understand what it isn't. So when you've used that term. So step one, observe natural phenomena. So in your example, there wasn't a natural phenomena being observed. You're just measuring angles to stars.
That's not exactly correct, because I'm observing the natural phenomenon of the celestial paths, and I'm asking the question.
Okay.
Why are they in the shape?
Just stop. Yeah, if you're observing the path of the stars, then the path of the stars is your effect that you're studying. Therefore, in the hypothesis, what you'll have is a presumed cause for that very specific effect. So the causal relationship is you suppose X will cause the movement of the stars in this instance. Because that's the...
Exactly.
So are you varying an independent variable to manipulate the movement of the stars? No.
I'm not following you exactly. With what do you mean? Am I varying an independent variable? Can you just elaborate on that a little bit?
Sure. So after step one, you've observed something occurring in nature that you want to know why that happened. Step two is to suppose what you think causes that effect. So first you establish something called a dependent variable. That's a naturally occurring phenomenon. Then you suppose a cause that you can vary as a researcher, and that's called the independent variable. By the time you've got those two things, you've then formulated, by default, something called a scientific prediction, otherwise known as a hypothesis. And the hypothesis states what you think causes the effect you observed in nature. That would be
okay. I'm following you now. Okay.
Right. So to understand that to formulate an experiment is to suppose an if and then relationship with something observed in nature, you can then formulate a null alongside it, which is a statement that says, if my supposed cause, then I won't induce the effect I'm studying. That's called a null hypothesis or zero difference result. Once you've got both sides of the prediction, that's if A, my presumed cause, then B, the effect that I've observed in nature, and a null, if my presumed cause, then I won't induce the effect observed in nature, then you've got a scientific prediction. And upon variation of your presumed cause, you can either induce the effect or not induce the effect, and therefore validate one of the two suppositional statements, proving your prediction. That's science, as opposed to false dichotomies, what-if questions, and so on and so forth.
And to the two models, we know how all the models, what measurements created those models, or what they're called models. They're not really models, but we know how they were formed. So when you say angle, it triggers something in us because we know what's getting ready to happen, which will be a false dichotomy.
So Jardo sent a super chat but has retracted the message. So I don't know what he actually said. But thank you for the super chat, Jardo. Really appreciate all the support today. But yeah, again, just to round that out, when he was laying down his example, all I'm hearing, the first thing he said was axis, right? We all heard axis. Well, John, if you beg my indulgence, what goes through your mind when you hear axis?
Yeah, plane of reference.
Yeah, a description that requires a plane of reference for the axis to be described from. So immediately you're into the requirement of a flat plane. So conceptually, for me, it's a real struggle when you're like, no, I'm describing how it works in the globe model. I'm like, I can't even conceptualize a globe model now when I try and tie it to a reality that we actually experience, because in that reality, we start with measurements of a flat plane to describe the axis of rotation of a sphere Earth. It makes no sense. So I literally struggle to conceptualize globe models now because I know what the Earth's measured as. How can you conceptualize I can't even say it now. How can you conceptualize a flat plane not being that when that's what you're measuring? It's a struggle for me, personally. I just can't do it anymore. When someone says globe model, two things that ring through my head. The first I've just went through. The second is QE going, okay, show it us. What model?